Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 18, 2025, about 3 days ago. This paper introduces a two-step system, DoubleurNet plus BokehNet, that refocuses a single photo while giving flexible control over bokeh strength and even aperture shape by mixing synthetic training pairs with real bokeh images guided by EXIF metadata. The paper is titled, Generative Refocusing, Flexible Defocus Control from a Single Image. And as we will see later, the approach points to a pretty practical path for realistic, user-controllable refocusing. Also, the authors shared a GitHub repo for Genfocus, and it is set up as a practical inference demo. You will find installation steps, links, and commands to download the pre-trained weights, and a Gradio-based interface you can launch via demo.py. There are also example assets and Python requirements to get running quickly. Figure 1 shows what the system ultimately buys you, which is a single photo that behaves like a virtual camera with adjustable optics. The full panel grid summarizes 4 controls, so you can either increase blur, move the sharp plane, or change the bokeh shape. The top left sequence varies aperture size, which changes depth of field from strong bokeh to all in focus. The bottom left example shows heart-shaped bokeh from point lights, and the right side combines focus shifting with blur strength. Table 1 makes the core claim concrete, which is that the proposed system covers more real-world inputs and controls than prior refocusing methods. The full table contrasts input setup and training data, so you can see which approaches require an all-in-focus photo and which rely on synthetic paired supervision. The supported user control columns highlight a key gap in baselines, because aperture shape and full focus control are often missing or limited. Figure 2 explains why the method gets both robustness and control, because it splits refocusing into 2 separate jobs. The full diagram shows a first stage, DoubleurNet, that turns a blurry input into an all-in focus image, optionally helped by a conservative pre-deblur. The right side shows BokehNet, which takes that sharp image plus a defocus map to synthesize bokeh. The defocus map uses depth, a chosen focus plane, and a bokeh level, and an optional aperture shape steers the blur pattern. Figure 3 explains where the training supervision comes from, so the model learns real-looking blur without needing perfectly captured refocus pairs. The full graphic lays out 3 routes, which all end in the same 5-piece training record. The left panel shows synthetic paired data, where a real all-in-focus photo and depth produce rendered bokeh. The middle panel shows unpaired real bokeh, where EXIF metadata provides camera settings for bokeh level. The right panel covers real pairs without EXIF, where the bokeh level is estimated instead. Table 2 shows that the DoubleurNet stage is not just plausible visually, it also wins on standard perceptual metrics for recovering an all-in-focus image. The left half reports results on real DOF, where lower LPIPS and FID mean closer to the ground truth, and higher clip IQA, Manica, and music mean better perceived quality. The right half repeats the story on DPDD. General Refocus lands the best scores across every column, which supports the choice to use diffusion with pre-deblur conditioning. Table 4 shows that the full DoubleurNet plus BokehNet pipeline wins on end-to-end refocusing quality, not just on the deblurring stage alone. The bokeh level is tuned per image with a binary search, which means the baselines get a fair shot at matching blur strength. The bottom row with DoubleurNet and BokehNet has the best perceptual scores overall, including the highest clip image and music, and it also keeps distortion low. Alright, 2 takeaways stand out. The first takeaway is that splitting the problem into DoubleurNet for all in focus recovery and BokehNet for controllable blur makes single image refocusing both higher quality and more editable. The second takeaway is that mixing synthetic pairs with real bokeh, guided by EXIF metadata, helps escape simulator bias and match real lenses. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.